Okay, integration of polynomial functions. All right, let's just go straight into the example. So example 11 says, find the integral of 6x squared minus 4x cubed plus x, and of course we're integrating with respect to x. Not really difficult. For a power integral, what you're going to do is that you're going to increase the power of x by 1. So this is 6x cubed, and then we're going to divide by the new power, which is 3, minus 4. We're going to increase the power of x by 1, so this is x to the 4, then divide by the new power, which is 4. For x, we're going to increase the power by 1, so this becomes x squared, and divide by the new power, which is 2, plus c, which is the constant of integration. So this would come out to be equal to 2x cubed minus x to the 4th power plus 1/2 x squared plus c. So dividing by 2 is the same as saying multiply by a half. All right. So let's move on to the next example. Example 12. Example 12 says find the integral of 3x cubed plus 4x squared minus 2x plus 1 dx. Well, so that would be equal to 3x to the 4. We're going to increase the power by 1, then divide by the new power, which is 4, plus 4x cubed, divide by the new power, which is 3, minus 2x squared, divide by the new power, which is 2, plus what? When you integrate 1, you're going to get x, plus c, which is the constant of integration. So this would be equal to 3/4 x to the 4 plus 4 over 3 x cubed minus x squared plus x plus c. Example 13. All right. Example 13 says, given that f of x is equal to 6x to the 5th power minus 3x squared plus 4x plus 12, we're to find the integral of f of x. All right, so in this example, the integral of f of x would be equal to the integral of 6x to the 5th power minus 3x squared plus 4x plus 12. And of course, we're integrating all of this with respect to x. So for power integral, you're going to increase the power of x by 1 and then divide by the new power. So this becomes 6x to the 6th power, divide by 6, minus 3x to the 3rd power, divide by 3, plus 4x squared, divide by 2, plus 12x, and then add c, which is the constant of integration. So this would come out to be x to the 6, because 6 cancels 6, minus x to the 3rd power, again 3 cancels 3, plus 2x squared plus 12, that should be 12x here, plus 12x plus c. Example 17. In example 17, we're integrating. All right, so the integral here, this would be equal to the integral of 6x x to the fourth power plus x raised to the half power minus 3x to the 2/3 powers, and I'm integrating all of this with respect to x. For a power integral, we're going to increase the power of x by 1 and then divide by the new power. So this becomes 6x to the 5th power divided by 5 plus x to the 3 over 2 divided by 3 over 2. Alright, so the power of x in the middle there is x raised to the half power. When I add 1 to a half, I get 1.5. Now 1.5 is the same as what? 3 over 2. So the new power would be 3 over 2. Then I would also divide by the new power, which is the divide by 3 over 2. Minus 3 raised to the power 5 over 3. Now remember, we're to add 1 to the power. So this would be 2 over 3 plus 1. Now 1 could be the same as saying 3 over 3. So 2 over 3 plus 3 over 3 is 5 over 3. And then I must divide by the new power, which is 5 over 3, plus c, which is the constant of integration. All right, so let's finish up this question. So this would be 6 over 5 x to the 5th power plus 2 over 3 x to the 3 over 2 power minus 3 over 5 multiplied by 3 x to the 5 over 3 power plus c. So here, dividing by 3 over 2, when you divide by a fraction, it's the same as multiplying by the inverse of that fraction. So dividing by 3 over 2 is the same as multiplying by 2 over 3. So dividing by a fraction is the same as multiplying by the inverse of that fraction. So dividing by 3 over 2 is the same as multiplying by 2 over 3. So here, our final answer would be 6 over 5 x to the 5th power plus 2 over 3 x to the 3 over 2 power minus 9 over 5 x to the 5 over 3 power plus c. Example 18. All right, so in example 18, we're going to integrate t squared plus 1 over t to the 4, and we're going to integrate that all of that to the with respect to t. All right, well, this would be the same as saying the integral of t over t squared over t to the 4 plus 1 over t to the 4. And I'm integrating this with respect to t. So this would be the integral of t to the minus 2. So t squared divided by t to the 4 is equal to 1 over t squared. And 1 over t squared is t to the minus 2 plus t to the minus 4. And I'm integrating this with respect to t. So 1 over t being t to the minus 4 is the reverse application of this law of indices, which says that a to the minus n is equal to 1 over a to the n. So 1 over a to the n is equal to a to the minus n. So it's the application or reverse application of that law of indices. Now, for a power integral, as we said before, we're going to increase the power by 1. When you add 1 to minus 2, you're going to get minus 1. So this is t to the minus 1 divided by the new power, which is minus 1, plus t to the minus 3 divided by the new power, which is minus 3, plus c, which is the constant of integration. So to finish, this would be equal to minus 1 over t. So it's again applying our law of indices. A to the minus n is equal to 1 over a to the positive n. A positive divided by a negative makes this a negative 1 over 3t cubed plus c, which is the constant of integration. So t to the minus 3 going to becoming 1 over t cubed is the application of the law of indices, that a to the minus n is equal to 1 over a to the n. All right, let's look at our next example. Our next example is example 19. Let's just do a quick check to ensure that we're not missing an example. Yeah, we just did 18. So, example 19. In example 19, it's a similar idea. This would be equal to the integral of t to the 3 divided by t to the half power, 1/2 power, because the root of t is the same as saying t to the half power. This is t divided by t to the half power. And we're integrating all of this with respect to t. So this will become the integral of t to the 2.5, which is the same as saying t to the 5 over 2. All right. Remember, if you're dividing and the base is the same, you must subtract the indices. If you subtract a half from 3, you're going to end up with 2.5. 2.5 is the same as saying 5 over 2. Plus, and this becomes t to the 1/2 power, and we're integrating with respect to t. Now again, if we are dividing, so I'm dividing t by t raised to the half power, and the base, which is t, is the same. I must subtract the indices, so that would be t to the 1 minus a half, which would be t to the half power. Now let's integrate. We're going to increase the power by 1. So this is t to the 7 over 2, divide by the new power, which is 7 over 2, plus t to the 3 over 2, divide by the new power, which is 3 over 2, plus c, which is the constant of integration. All right, so here, remember, for a power integral, we must add 1 to the power. So the power was 5 over 2, so it's going to be 5 over 2 plus 1. I could view 1 as being 2 over 2. So 5 over 2 plus 2 over 2 is 7 over 2. All right, so you divide by the new power, which is 7 over 2. 1/2 plus 1 is 1.5, which is the same as saying 3 over 2. And of course, you divide by the new power, which is 3 over 2. So our final answer would be 2 over 7 t to the 7 over 2 plus 2 over 3 t to the 3 over 2 plus c, which is the constant of integration. All right, so we'll end this video here, and we'll continue the next set of examples in the next video.